Greetings. Today I want to talk to you about sequences and patterns. Patterns have some really interesting applications, for example, predicting the weather, decoding military messages, mapping the spread of the Ebola virus through Africa in 2012. However, today I want to talk about something much more boring than that. I want to talk about a question I had when I was in Year 9. So my teacher said this. My teacher said, anything to the power of 0 equals 1. Now that's kind of weird. You can't multiply a by itself 0 times. What does that even mean? So if we look at a pattern, we can use that example to determine why anything to the power of 0 might equal 1. There's an exception to that rule too, if you're thinking about it. What's the exception? A itself can't equal 0. So let's start with a number that isn't 0. 2. 2 to the power of 1 is 2. 2 to the power of 2 is, well, that's 2 times 2. There's 2 of them. 2 times 2, that's 4. 2 to the power of 3, 2 times 2 times 2, 8. You get the picture. Look, and I could use this pattern to say, okay, great, what's 2 to the power of 100? Right now, I don't know the answer to that question, but I could use the pattern and maybe a formula to work that out. So if we work backwards instead of forwards, 2 to the 5, 2 to the 4, what have I done to get from 32 to 16? I've multiplied by half. You can also think of that as dividing by 2. And again, dividing by 2 or multiplying by a half. And again, and again. And suddenly, the only answer that makes sense, the only one that fits in with the pattern, is 2 times a half, which gives you 1. Hence, I can conclude that anything to the power of 0 equals 1, as long as that thing is not 0 itself. So if a does not equal 0, that is an if a does not equal 0, then a to the power of 0 equals 1. And I've just used a pattern to show you why that might be. What kind of pattern is this? Well, to get from the very first term, 2 to the 0, down to all the subsequent terms, I've actually multiplied by 2 each time. And since I'm multiplying by the same number each time, this pattern or this sequence has a name. It's called a geometric sequence. So what is this pattern? It's a geometric sequence, sometimes called a GP, geometric progression. I hope this helps, and goodbye.